Hello everybody, welcome to episode 12 of Remaking Cavestory in C++. This is an episode about animated tiles. I am Limeoats, my website is limeoats.com, my Twitter is @limeoats, my GitHub account is here at this link, and my subreddit is here at this link. So as the title suggests, we are going to focus on animated tiles today. So what does that mean? All of our tiles currently just sit still. We want tiles that are animated on the screen, and on top of that, we can also get them animated in tiles, which is really nice. So when we're making our map, we can actually visualize with the tiles actually moving. So that'll be nice. So we want them animated in the tiles as well. And our map isn't quite complete yet, because if you're familiar with the first map of Cavestory, there's a heart container and a save disk in this map too. So if I run what we have so far, here we are. This is where we left off last time. Right over here, there's actually a slope here that shouldn't be there, so I'm going to get rid of that. But right over here, there's a supposed to be a heart container and a save disk. So I'm gonna get those in there now with our animated tiles. Alright, so there are a few details that we need to know before doing this. First of all, we need a new tile set. It's at the path npc/npc sim. So we need to convert that to a PNG and get that into our tile sets folder. Then the way animated tiles works, it's very similar to our animated sprites. There's a duration, and that's the amount of time between each frame in the animation. So what we're going to do is we're going to have our save disk's duration is going to be 100, and our health duration is going to be 10. You'll see what that means once we get it all implemented. So, what do we need to do? First, we need to fix our animated sprites update. Someone left a comment, I believe it was on Reddit, they commented on one of the videos saying that there was a bit of repeated code that I didn't notice that I repeated. So we're just going to replace that with a call to a function that does the exact same thing. Then we need to convert our PBM file to a PNG and put it in the tilesets folder, just like we've always been doing. Then we need to create the tiles in tiled. And when I say create, I mean place them in our map and get them all animated within tiled itself. Then we need to fix tile loading. Currently, there's actually a pretty big bug with the way we're loading our tile sets that prevents multiple tile sets from working at the same time. So we need to make a couple of little changes to our tile set loading code. Then we're going to create an animated tile class similar to our animated sprite class, except this one's for tiles, obviously. I think there's like a little structure in there too that we're going to create. No big deal. Then we're going to parse the animation out of the TMX file, and then finally we're going to modify the level class to use our new animated tile. Alright, so let's get started right away. First we're going to fix animated sprites update. So go to animatedsprite.cpp. And what we're going to do, if you look in update, down here we have two lines. It says frame index equals 0 and animation done. If you look up here now at our stop animation function, it does the exact same thing. So all we're going to do is we're going to replace these two lines here with a call to stop animation. Okay, so that just gets rid of some repeated code. If we ever need to change stop animation, we don't have to change it in two places. We just change it in the function, and it'll just work there. So just better to have it like that. The next thing we're going to do is we are going to convert our PBM to a PNG and get it in the tilesets folder. So why don't you go ahead and go to npc/npc sim. Copy that, and then you're going to get it into your tilesets folder. So drop it in there, open it up. Export as PNG. Close out of that. It's in there. Delete the PBM. Good. So that's all we'll need from there for now. Now it's in our tilesets folder. Let's make sure, refresh. Good. Alright, so now that's done. So the next thing we need to do, according to our notes, is create the tiles in Tiled. So go ahead and open up Tiled, open up your map. This is our map. First things first, click on slopes. Delete this little tile here. We don't need it. Little slope can go. Alright, because something else is going to go there now. So now, yeah, what we're going to do is we're going to go to layers, click on tile layer, and now down here in tile sets, click on this little new tile set thing, type in npc sim as the name. The source is going to be our npc sim.png. Still 16 by 16 for tiles size, that's fine. And now when you click OK, you're going to have another tab here, and now you'll have this tile set in here as well. So what I can do, you can just obviously place a little save disk there where it belongs, but it's not animated, so that's no fun. So what you're going to have to do, well, before we animate it, why don't you just go ahead and place a save disk there and place a health thing here. We're going to fix the tile loading before we actually start animating this thing. So if you place those there, it'll show up on your map, it'll be fine. Make sure you have tile layer selected here before you place them. Save it, and then try to run your program. And you're going to see something weird. You're going to see nothing. Even though you place them and they show up in tiled, you see nothing here. And that's because our tile loading code is wrong. So we have to fix that. We have to get these things to show up here. So the reason that's happening is because we're only loading one tile set. So let me show you why. Go to level.cpp and go down to our we are loading all the tile sets correctly, but we're not getting it for the correct GID. So go down to where we have this comment, get the tile set for the specific GID. And we have to change this. And this has to become... Okay. So yes, we're still getting our in attribute GID. However, what's going on here right now is we're looping through all of the tile sets, and we're checking if the first GID is ever less than or equal to the GID we're on. And if it is, then we automatically just choose that as our tile set. But this is, it worked the first time, but it's not going to work anymore because it's slightly flawed logic. Say our gid is like 90. Okay, our first gid from the first tile set's always 0. And our first gid for our next tile set might be like 60. So obviously we want the second tile set because it's closer to our 90. So what our logic here says right now is the first time around it'll get the first tile set, which will be the one that starts with 0. Our first gid is 0. And yes, 0 is less than 90, so it's automatically just going to take that first one and break instead of taking the one that's actually closest to our gid. So all I need to do for that is then, to fix this, is figure out which one is less than and closest. So both less than our gid and closest to our gid. So I'm going to make a variable here called int closest equals 0. Then we're going to loop through all of our tile sets still. And then this if statement still applies because we still do want it to be less than or equal to our gid. So that's still valid. But we have another if statement then. If tile sets at I first gid is greater than closest. So our closest starts at 0, and then if our one that we know is already less than gid, so it's a candidate, it's possible that it's the right one. If it's greater than closest, that means that it's closer to our gid, meaning we want it. Then closest equals that one. Tile sets I first gid. And we'll set our tile set equal to that one. And then it'll go around the loop again. It'll go around the loop again and again and again and again for each of our tile sets. And if it ever finds one that is closer to our gid, then it'll take that one and set tile set equal to that one, until eventually we go through all of them and we realize that we have the correct tile set. So that's how we load tile sets correctly. So once you do that, build that and run. And now something shows up. It's not what we want, but it's something. And these are from the second tile set. So that proves that we got the tile set all figured out. The rest of our map is still fine because the first gid was 0 and it was closer to that. So that's fine. But now these are coming from the correct tile set, but it's the wrong tile. So the question is, why? Why is it the wrong tile? And what we need to do now is we have to go down to our code where we get the position of the tile in the tile set. So our logic here is a little flawed as well, to get the position of the tile in the tile set. The reason it's not flawed for the first tile set we load, but it's flawed for the second one because we're still using gids as if they were from the first tile set starting at 0. So what we actually need to do here on our int amount here, we need to do gid minus tls dot first gid. So when our tile set is has a first gid of 0, which is our first tile set, this won't do anything and it'll work just like it always has. However, when we have another tile set, let me actually show you what it looks like when we have a second tile set in here. So now we have two tile sets, see? So our first tile set here, our PRT cave, has a first git of 1. Oh, I'm sorry, I keep saying 1. I mean 0. It has a first git of 1. Our second one, though, has a first git of 81 because there were, I guess, 80 tiles in the first one. So now the second one starts at 81. However, if you find where we have the disk and the health thing, our git is 99. So our level loading code originally was just going to take 99 minus the width and the height, but it's never accounting for this first git. We need to get all the way back down to a lower number here, so that it's like a zero-based number where, because we're getting widths and heights of the tile set. The tile set width and height doesn't change or scale up depending on the first gid. It's still going to be however many pixels, just like the first one. But the gid is much higher, so we need to then subtract the first gid to get back down to that number. So if you save that now and load up your game, the disk and the health things show up correctly. And that's perfect. They're not animated or anything, so we didn't set that up yet, but they're there. So it's now taking the correct tile from the correct tile set. Okay. So now that that's done, we're going to animate that tile in Tiled. So go back to Tiled. You can actually delete those two because we're going to animate them. So click on the disk first. Go up to View, and then Tile Animation Editor. So now what you're going to do is you're going to double click on each of these 6 disk images. Oh, 8, I mean. 8 disk images in order. And you'll notice down here in the corner it starts spinning. It's going through each of these frames. Once you get all of them, the disk is now spinning. So what that means now is that if you hit close, because we're going to leave the duration at 100, we decided. Hit close. Now if you select this first disk space tile, you'll have a spinning disk that you can put anywhere. So if you drop that there, now it's spinning. You can do the same thing now if you click on the heart container thing, go to Tile Animation Editor, and double click on that one and the one right next to it to the right. We're going to set the duration of this to 10 and 10, so that it just flickers a lot. Close that, drop that there, save that. And that's how we have our tiles animated within Tiled. So that was pretty easy. So what's next? Fix the tile loading, we did that. Fix the tiles and tiles, or create the tiles and tile, we did that. Create the animated tile class. So before I do that, I'm going to show you what this looks like. So this is what our animations look like in our TMX file. So note that it's within the tile set element here. So this tile set element's been here the whole time, but now we have new child element inside it called tile. The ID of this tile is the first tile in the animation inside the tile set, and then there's an animation element underneath that, and then underneath that there are frame elements, which are each of the tiles in the animation and their duration. Now the way we're implementing this, we're not going to make it so that we can have different durations per frame. You can do that, but it's not really necessary right now, and it would require more code than I feel is necessary for this tutorial. So we're just going to make all of our, within one single animation, they're all going to have the same duration, which makes sense. We don't want parts of the disk spinning faster than the rest or anything. It would be weird. So that's how that's all set up. So we're going to have to parse this out. We're going to start though by creating a new class called animated tile.h. So go in your headers folder, create animated tile.h, and let's implement it. So if not defined, animated tile h, define animated tile h, and if class animated tile, and this animated tile class is going to extend off of our tile class because all animated tiles are still tiles. Public private. Protected. So public, we're going to have animated tile. Let me do private first, I guess. It's good to have our variables in there. A vector of vector2's tile set positions. These are just the positions of each of the frames within our tile set. Tile to draw is which tile in the animation we're actually drawing at the time, and int duration is the duration. If we were to have different durations, we would have a list of durations and that would get messy. But we're just going to have one single duration for the entire animation. Protected, we're going to have an int amount of time equals 0. This is timer stuff, so that's why I'm putting in protected. We might use that later on in a derived class from animated tile. So it's good to have that in there, just like I have it in tile. Public, we're going to have an animated tile constructor, taking in a vector of vector2's tile set positions, int duration, SDL texture, tile set, vector2 size, and vector2 position. Most of those just go into our tile base class. Some of them fill up these variables in this class. Void update, that's where we're going to change the frame that we're drawing. Or, well, yeah, we're going to change which tile to draw with a timer. And void draw, which is obviously where we draw our tile from. We need to include vector. We need to include tile.h, and we're using vector2, so we need to include globals.h. Okay? Now, I'm also going to, underneath this class, create a structure. It's going to be struct animated tile info. This is information related to an animated tile, but I don't want it inside the animated tile class, and you'll see why in a bit. But for now, it's just going to have some public members, just to keep them all grouped together. Tile sets first GID. So it's the first GID in the tile set for our animated tile. Start tile ID. A vector of int tile IDs. Those are each of the tile IDs in our animation. And if you remember what a tile ID is, it's each of our frames have a tile ID, and that's just the GID of where in the tile set it is. So keep track of all of those, and also int duration. Okay, I start all of my public variables with a capital letter, so I remember. All of my private variables, I start with an underscore. Okay, so Now let's implement this class. So create a animated tile.cpp. You're going to include animated tile.h. And also graphics, because we're using that. So animated tile. This is our constructor. Again, it just takes in a vector 2's, tile set positions, duration, STL texture tile set, vector 2 size, vector 2 position. Let me shorten this. Okay. We're going to initialize those. We're going to call our tile constructor, which takes in tile set, size, tile set positions at 0, so the starting point, and position. Tile set positions will set equal to tile set positions. Duration will set equal to duration. And tile to draw can just start out at 0 because we'll just start at the first frame in the animation. Okay. Now the reason we're using tile set positions at 0 here, a tile wants to know the position of the tile within the tile set. Now we have an animation going, so it's going to be looping through a bunch of them, but in order to initialize a tile, it wants to know something. So we'll just give it the first spot. So if for some reason the animation didn't work, it would just draw the first spot as a regular tile. Okay, then we just have our update and our draw to do. So animated tile update. And this is just like our animated sprite code. It's actually the same exact algorithm. So if amount of time is less than or equal to 0, then if tile to draw equals the end of our list of frames, then go back to the beginning, start from the beginning, drawing our animation from the first frame. Otherwise, just tile to draw plus plus, go on to the next frame, then set amount of time equal to duration to start it over. Okay. Else, if we're not at the end of our duration for this frame, just subtract elapsed time from amount of time, and then call our tiles update. Okay, that's it. And then finally, animated tile draw, and this isn't very complicated either. It's really the same thing we've been doing, except we're just going to pass in our tile to draw instead of a specific position in the tile set. So this is standard. Okay, that's the usual, just draw at position with the size. Same thing as always. Now for source rect though, we're going to use tile set positions at tile to draw for X. Same thing for Y. And then just size.x, size.y. And then finally, just split surface, tile set, source rect, and dist rect. Okay. Standard, nothing really weird going on there. Tile set is a private member of tile. Go to tile.h and move, move this stuff. Change private to protected, because now it's a base class, so we should change private to protected. Build again, everything builds, good. So it's still not doing anything if we run our program. Same thing, because we're not using it yet. These are still regular tiles. We don't want that. Interesting though, notice how in tiled, they're animated. But since they're on the tile layer, they're still considered tiles. So our code here in animated tile, when we create a tile right here, that's causing it to get drawn with the first frame. Alright. So now, parse the animation out of the TMX file and modify the level class to use our new animated tile. Okay, go to level.cpp and, well, first actually go to level.h. We need a new list. Alright, so 2 new lists. We're going to include at the top animated tile.h. So underneath our list of slopes, we're going to say vector of animated tile list, and a vector of animated tile info, animated tile infos. Okay. Now go to level.cpp, and we are going to parse our animations out of our TMX file. So go up to the top, find loading the tile sets, because all of our animation info is in our tile set element. So if tile set is not null, while tile set, get our first GID, do all this stuff, push it back. Wonderful. Now, before moving on to the next tile set, we need to get our animation stuff. So get all of the animations for that tile set. XML element p tile a for tile animation equals p tile set first child element of type tile. Because if we look at our thing, underneath tile set we have tile. Then we're going to get the ID, then animation, then frame. If p tile a does not equal null, while p tile a equals, it should be a capital T, p tile a next sibling element. Okay. So we're going to create a new animated tile info here called ATI. And we need to store some information. Now the reason why I created a separate structure for animated tile info is because when we're actually parsing the TMX file, we need to keep track of a lot of stuff here, but we're not creating the actual tile yet. We need to do that down below when we're dealing with the tile set, locations, and all that stuff. But we need to store a bunch of information in the beginning. So we're going to create a list of animated tile infos and then build our animated tiles off of that. So we can start by saying ATI.startTileID equals pTileA int attribute ID. Now, I'm going to say plus first GID. Now, the reason I'm doing that is because if you look on this one, this is our health one. Our tile ID is 18. Our first GID is 81. If we were to go down below to where our actual thing is, we'll notice that the GID is 99, which is 81 plus 18. So we need to consider that. Our animation doesn't consider the other tile sets. So we need to use first GID to figure out the actual GID here for the start tile ID. So we add 18 plus 81, ID plus first GID. We're also going to say ATI.tilesets first GID equals first GID, because it's obviously our tileset's first GID. Okay, then we're going to say XML element. Time to move on to our animation element. P animation equals P tile A first child element of type animation. If P animation does not equal null, while P animation equals P animation next sibling element animation. Okay, while P animation. There's nothing really interesting in the P animation one. We need to actually get the frames within the animation. So let's move right on to the next one. XML element P frame equals P animation first child element frame. If P frame does not equal null, while P frame equals P frame next sibling element frame. Okay, so now we're on our frame. We need the tile IDs and we need the duration. So ATI.tileIDs.pushback pframe int attribute tile ID plus first GID. So every time around this loop, we'll get all of our frames, push it back into our tile IDs, and that will be good. We'll have all our IDs. And ATI.duration equals pframe int attribute duration. I understand that it's going to be the same every time because of the way we're implementing it, and it's going to rewrite it every time, but that's okay. That won't be too costly when loading the map. Don't worry about that too much. Then finally, once all that's done, we need to actually add this animated tile info object to our list of animated tile infos. So this animated tile infos dot pushback ATI. And that's it. That is how we parse our animation out of our TMX file. So now that that's done, now we just need to use that list of animated tile infos to build actual animated tiles. So the first thing I'm going to do is I'm going to go down to this where we calculate the position of the tile in the tile set. And what I'm going to do is I'm actually going to I'm going to go down to the bottom of my, go back to level.h. And what you're going to do is in private down here underneath load map, we're going to make a function. We're going to say vector2 level get tile set position. passing in a tile set, a GID, a tile width, and a tile height. This is going to do exactly what we have written already in our code, but we're going to be using it in two different places now, so I want to factor it out into a function, so it's only being used once. And then we just call it twice. So I'm just going to implement it. And all you need to do is go up to wherever that was, here, calculate the position of the tile and tile set, copy it, well, I guess cut it, paste it, and it returns a vector 2, so instead of just stopping there, we're just going to return final tile set position. So now what we can do is up here, where we got rid of that, we can write vector 2 final tile set position equals this get tile set position TLS GID tile width tile height, and everything should work exactly as it always has, and it does. Great. So now we can use that get tile set position for anything. So what we're going to do is in here, notice how we're building a regular tile. Instead of that, we have to check to see if we want to build an animated tile instead for this specific GID. So I'm going to say bool is animated tile equals false. I'm going to create a temporary animated tile info. Then I'm going to loop through all of my animated tile info. So for int I equals 0, I is less than animated tile infos dot size I plus plus. If animated tile infos at I dot start tile ID equals GID, then what that means is that we've hit an animated tile. So I'm going to set our ATI equal to animated tile infos at I. I'm going to set is animated tile equal to true, and I'm going to break out of this loop. So that means we know for sure that the GID we're on is an animated tile. So now what I'm going to say is if is animated tile is true, we're going to create a vector of vector 2's, which will be tile set positions. Okay. Then we're going to loop through the tile IDs in that animated tile info object we have. And we're going to add all of the positions on the tile set to our tile set positions vector we just made. And to get the positions, we're going to call this function that we just made, get tile set position. That's why we factored it out. Otherwise, we'd have to write all that ugly code again. Instead, we could just call the function. So that takes in TLS, again, because it's still the same tile set, ATI.tileIDs at I, tile width, and tile height. Alright. And at this point, it's going to create the animated tile. So I'll create a new animated tile object called tile. Tile set positions, ATI.duration. This is just the constructor for animated tile we made before. TLS.texture, vector2 with tile width and tile height. And final tile position. And add it to the list of animated tiles. And that's it. Then we need a nice big else here. This means it's not an animated tile. So we're going to go and create our tile just like we always have. A regular static tile. Don't change anything there. And that should be it. It builds. None of this is too complicated. Really, you just have to understand why we have this list of animated tile infos. It's so that when we parse it out in the very beginning, we keep track of all that information so that down here, when it's time to build the actual tiles, we can get all of these start tile IDs and get the positions of each of the frames in the tile set. Alright, so now what we need to do is go down to our update, loop through all of our animated tiles, and just call update, passing in elapsed time. That'll take care of all the updating. And then also down here in our draw, we need another for loop for our animated tile list. And we need to draw them. Passing in graphics. Now I think update's already being called, and I think draw's already being called. So if we run it, we might see animation. Instead, we get builder. No member name draw in animated tile. Huh? Pretty sure we made a draw function. It's right here. That's interesting. Oh, that's because I never put @I. That's an important detail. Run that. And we have our disk rotating. We don't have any animation on our heart container though. I'm not sure why. I was not expecting that. Alright, so let's find out. So we're looping through all of them. We're not just using like the first one or anything weird like that. It's definitely in here. There's nothing wrong with that. With a duration of 10. Well, when something like this happens, we need to debug. So we're going to printf a high every time it adds an animated tile infos to the list. We should see 2 highs if they're both animations are getting registered. And we see 2 highs right here in the console. So that means it's definitely making it, definitely adding the animated tile info, so that's good. So next thing we can do is down here where we create our animated tiles, right before we push back or after we push back, I'll printf again, hello. And we'll see what gets printed. vector. 9. Where do we get 9 from? Oh, I see. Okay. So, the reason this is happening is because we were supposed to close this for loop right after we push back our tile set positions. We don't want to create this many animated tiles. We don't want to create as many as we have here. One animated tile for the entire animation. We need this tile set positions thing, vector, to use in here, so we need it to be full of everything. We want that to fill up before we create the animated tile. So now, I kind of expect it to work. And it does. You can see that it's now flickering exactly as we have it entiled here, flickering. So, yeah. So here it is, flickering nicely. Yeah, that's our tile animation. Now, just to show you, if we were to go into our TMX file and change our duration to, say, 40, you'll see that it slows down when we run it. So it's flickering a little bit more slowly now. And you can just play around with that. I like 10 because I like the fast flicker. Doesn't really matter too much. Looks good. And that's how you have tile animations. So you can make any tile animate now just by adding it in there with the animation editor and tiled. Alright, so we can talk briefly about next time. I didn't actually plan out what I'm going to do next time, so let me figure that out right now. There are a few options. We have a lot of different directions we can go in right now. We can work on the HUD, like the health and the experience and all that stuff. We can work on... We can make an enemy, but I'd like to wait until we get into the second map to make the first enemy. So I don't think we're going to do that just yet. We can make quote look up and down. That'll probably be a very quick episode. What else do we have to do? The camera can wait until the next map because the next map will be bigger. Guns. We need our guns. But again, that could wait till the next map. I guess next time I'll work on... I'll make a short episode of just looking up and down while you're in the air and when you're on the ground. That'll be kind of important. And then after that, we'll work on the HUD, getting the health to show up on the screen and all that. And yeah, well, then we'll take it from there. Then we'll probably, after that, work on getting out of this first map, so going through the door into our second map. But for next time, we'll say, make quote look up and down. While walking, while jumping, and I guess we can also in that episode make quote look behind him, which is also in Cavestory interacting. You interact with things by pushing the down arrow and he looks behind him at whatever's behind him, and that's how he talks to things and that kind of stuff. So we'll work on that next time. So again, I'm Limeoats. My website is limeoats.com. My Twitter is @Limeoats. My GitHub account is here. All of this code will be there under release 1.12 at this point. And this is my subreddit where you can ask questions, have discussions. People will help you. Of course, tweet at me if you have questions you need answered quickly. I'll also respond to pretty much everything on Reddit. And yeah, thank you for watching, and I will see you all next.